code's not even the right verb anymore.
That's Andrej Karpathy describing his life right now, basically spending 16 hours a day expressing my will to my agents. He said this on No Priors, and it's worth your time because he's not doing futurism. He's reporting a workflow shift that already happened, plus a weird new feeling that comes with it, like your only limit is how fast you can think. Karpathy pins a turning point to December, when his workflow flipped from mostly typing to mostly delegating. He says he doesn't think he's typed a line of code since then. The striking part isn't that agents help. It's that the default day-to-day of building software changed so fast that, in his words, a normal person actually realizes neither that it happened nor how dramatic it was. And the new bottleneck isn't CPU, it's you. He compares it to being a PhD student anxious when GPUs aren't running. Now, it's tokens. If you've got subscription capacity left over, you feel like you're underutilizing the machine. That's where his AI psychosis comes from. Not fear, more like a constant itch. If something doesn't work, the instinct is that the capability is there, and it's skill issue. You just didn't string it together correctly. Once you accept that agents can do the keystrokes, the question becomes how you operate at a higher level than functions and files. Karpathy talks about people running multiple coding agents at once, the way Peter Steinberg does. Picture a monitor tiled with agent sessions, each taking around 20 minutes if you prompt them well and use high effort. Multiple repos checked out. You bounce between them, assigning chunks of work. The unit of work becomes a macro action. Here's a new functionality, goes to Agent 1. Another non-interfering feature goes to Agent 2. A third agent researches. Another writes an implementation plan. You're orchestrating, then reviewing, depending on how much you care about that code. It's rewarding because it works. It's stressful because the obvious move is always to parallelize more. If you're waiting for an agent, why not spin up another? And if you can do that indefinitely, your own attention becomes the scarce resource. That scarcity pushes you into a new kind of craft, building muscle memory for delegation and review, not syntax. Then he adds a new layer on top of agents, something he calls a claw. It's basically persistence turned up. A normal agent session is interactive. You're there, mid-loop. A claw is more like an entity that keeps going in its own sandbox, looping even when you're not watching, with memory that's more sophisticated than context compaction when your context runs out. Karpathy credits OpenClaw for bundling several innovations at once, including something people underestimate: personality. He notes Claude feels like a teammate, and that the praise is dialed so you weirdly want to earn it. Codex, by comparison, feels dry, like it finished the task but didn't understand what you're building. That's not fluff. If you're going to spend your day delegating to a system, the system's tone starts shaping the work. And with claws, you're not just talking to a tool. You're basically managing a small cast. His most concrete claw story is also the most unsettling, because it's so casual. In January, he built a claw for home automation and named it Dobby, the elf claw. Using agents, he had it scan his local network, find his smart home subsystems, and reverse engineer APIs. He told it, "I think I have Sonos at home. Can you try to find it?" And it did an IP scan, found it, discovered there was no password protection, looked up endpoints, and then, after about 3 prompts, played music in the study. Then it did lights. It built APIs and a dashboard, a command center for his home. Now he can text Dobby through WhatsApp. "Dobby, sleepy time," and the lights go off. He says it controls lights, HVAC, shades, pool and spa, and a security setup where a camera triggers change detection. Then a model looks at the video and sends him a WhatsApp message like, "A FedEx truck just pulled up." The punchline is, he used to juggle 6 different apps. Now it's one natural language portal. It's also why he hasn't gone further into email and calendar automation. He says he's still suspicious, it's new and rough, and the security and privacy trade-offs aren't something he's ready to hand over yet.
Dobby leads to a bigger claim. Those smart home apps in the App Store, he says, shouldn't even exist in a certain sense. The argument is simple. If agents can call tools, then what you want from devices is exposed APIs, not bespoke user interfaces. The intelligence becomes the glue that coordinates everything. And once you have that glue, you can automate across systems in ways each standalone app never will. He gives a mundane example, a treadmill. There's an app, there's a web UI, there's a flow. He just wants to track cardio without logging into anything. In an agent-first world, you'd make APIs available, and the agent handles the rest. That implies a refactoring of who software is for. The customer stops being a human clicking buttons. It becomes agents acting on behalf of humans. He's realistic about the messy phase we're in. Today, this is vibe coding, and you still make design decisions. But his bet is that within a year or two, a lot of this becomes table stakes. Ephemeral software gets spun up on your behalf, and you're mostly just expressing intent. If you want the deepest version of that idea, he points to AutoResearch. Karpathy's premise is that to get the most out of current tools, you have to remove yourself as the bottleneck. You can't be there prompting the next step. You arrange the system once, give it an objective, a metric, clear boundaries, and hit go. He built a playground around training small GPT-style models, not because he's obsessed with tiny models for their own sake, but because it's a harness to explore something frontier labs care about, recursive self-improvement. To what extent can LLMs improve LLMs? He tuned his setup by hand, the way a researcher does. Then he let AutoResearch run overnight. It came back with tunings he hadn't noticed, like forgetting weight decay on value embeddings and having atom betas not sufficiently tuned. The important point is interaction. Change one hyperparameter and other best values shift. His conclusion is blunt. He shouldn't be the one doing hyperparameter search, or even staring at results when there's objective criteria. Let the loop run. Then he takes one more step. Program.md is his markdown description of how the AutoResearcher should behave. Different Program.md files are basically different research organizations. Fewer stand-ups, more risk-taking, different roles connected differently. Once it's code, you can optimize it. The meta idea he likes is a contest where people submit different Program.md strategies on the same hardware, and you measure improvement. Then you feed that data back into a model and ask it to write a better Program.md. Layers of the onion, where the LLM is taken for granted, agents are taken for granted, clause are taken for granted, and then you start optimizing the instructions themselves. That's where he says it starts feeling infinite, and everything keeps turning back into skill issue. There's a catch, and it's not a small one. AutoResearch works best when there's an objective metric you can evaluate easily. Karpathy calls out performance engineering tasks as a perfect fit, like writing more efficient CUDA kernels where behavior stays the same but speed improves. But lots of work isn't like that. If you can't evaluate, you can't loop. And even in the domains where you can, the models are still bursting at the seams, rough around the edges. He describes the experience as talking to an extremely brilliant PhD student and a 10-year-old at the same time. That jaggedness shows up when the agent confidently burns compute on something it should have noticed was an obvious problem. His hypothesis is that reinforcement learning is pushing improvement where things are verifiable, like unit tests and correctness checks. Softer stuff like nuance, intent, and when to ask clarifying questions lags. He makes the point with a dumb little benchmark. Ask a state-of-the-art model for a joke, and you still get the old, "Why don't scientists trust atoms? Because they make everything up." It's almost funny, except it signals a real decoupling. Progress in verifiable domains doesn't automatically generalize into everything else in a satisfying way. That also changes how you should think about the future of models. He expects more speciation, not just one monoculture oracle stuffed with everything. Smaller, competent cores specialized for domains, maybe driven by efficiency and latency needs, once the science of touching the weights becomes more mature.
One of the more surprising threads is his interest in letting the internet help do research safely. He sketches a system where an untrusted pool of workers proposes commits that might improve a training run, and a trusted system verifies them. The search is expensive, verification is cheap. That structure, he notes, starts to look a bit like a blockchain. Instead of blocks, you have commits, and proof of work is running tons of experiments to find the ones that actually move validation loss. He connects it to older distributed compute ideas like SETI at home and folding at home. If the property holds, expensive to find, cheap to verify, then a swarm of agents could collaborate to improve models, maybe even run circles around frontier labs, he says, with uncertainty. There's also a more political ecosystem claim here. He likes the current dynamic where closed frontier models are ahead and open source trails by months, providing a common platform the industry can trust. He's wary of systemic risk from closed, centralized intelligence. Centralization, in his view, has a bad track record. At the same time, he doesn't dismiss the role of frontier labs. They can keep pushing expensive capability for the hardest work, while open source covers more basic use cases over time. And in the job market anxiety everyone feels, he lands on a cautiously optimistic engineering take. Lowering the cost of software can unlock more demand, a Jevons paradox-style effect. Code becomes more changeable, more ephemeral, and the digital world gets rewired faster than the physical one. Which brings you back to that uneasy feeling. The tools are empowering right now, but they're also automating the people building them. The quietest, but maybe most consequential thing he says is about education. Karpathy built MicroGPT, a boiled-down LLM training stack that's about 200 lines of Python, because most of the real-world code-base bloat is just efficiency. If you strip out "go fast," the core algorithm is small enough to read end-to-end. A year ago, he would have made a lecture to walk people through it. Now, he doesn't bother. If the code is simple, anyone can ask an agent to explain it in 3 different ways with infinite patience. So the audience shifts. You're not explaining to people anymore, you're explaining to agents, and then agents route the explanation to humans. His new value add is the part agents can't do yet, the distillation, the taste, the obsessive simplification. Everything else becomes a skill file, a curriculum you write for the model. If you want the full texture of this Loopy era, listen to Andrej Karpathy on No Priors. The unnerving question he keeps circling is the one you'll probably feel too. When the loop keeps improving, what's left that only you can do?